Welcome to your first video here in the Teaching High School Chems crash course. Glad you're here. Let's jump on in. So first lesson today is working on Intro to Chemistry. Basically, what is chemistry and where does it fit within the realm of science? Because this really is where everything starts, and I mean everything, not just simply this course. So first and foremost, what is chemistry? Chemistry is the study of matter and how it changes. So once again, most of the stuff around us that we see and interact with is matter. And a lot of it changes on a day-to-day basis. So chemistry really is foundational in that way because almost everything you look at is a chemical. Your body is made up of a bunch of chemicals. The bonds between the carbons and the hydrogens and the oxygens and the phosphorus and the nitrogens and the sulfurs that hold your body together is chemistry. The molecules in the air are chemistry. The trees and the plants and the grass are chemicals. Okay? So it's also the central science that without chemistry there is no biology. Without chemistry there is no physics. That it really is the central and foundational science to everything else. Now because chemistry is so broad, we're going to take it and divide it into branches. Now these are the four main ones, and there's more than this by leaps and bounds. But organic chemistry is the study of things that have to do with things that are alive primarily. Carbon-based chemistry, things that are alive or used to be alive primarily. Inorganic chemistry being non-organic. Physical chemistry is where physics and chemistry meet, dealing a lot with atoms and electrons and craziness. And then biochemistry, where life and biology and chemistry meet. And there's a lot of other types of chemistry as well. But before we get going too much further, I want to take a pause and go through a thought experiment with you real quick. So if I gave you two glasses of one filled with tap water and one filled with soda water. So the soda water is going to have this fizz thing going on. So you're kind of like, that's different. And so perhaps you begin to wonder to yourself, is there a chemical difference between tap water and soda water? Are they chemically different? And you kind of wonder, well, yeah, I mean, the tap water doesn't fizz, so something's got to be different. Something's got to be causing that. So we can kind of think through and what do we call fizz? Well, we call fizz carbonation. And so then you're kind of like, all right, does that mean there's something going on with carbon? Or if you had a little more chemistry knowledge, which we'll get to later, you would know that there's something called a carbonate ion. So perhaps carbonation is related to the carbonate ion. And so what can we test for? We could test to see whether this carbonate ion is present in the soda water but not present in the regular water. And if we could prove that, then we could maybe make some conclusions there. So we're going to add a chemical called copper 2 chloride or cupric chloride. And when we add this chemical, it reacts with carbonate ions, forming, and if they're present, it's going to form this cloudy blue solid that's going to eventually settle to the bottom of the container. And so when we add it to the tap water, nothing happens. We just get blue water. There's no chemical reaction. But when we add it to the soda water, we get this cloudy little solid particles of what is now copper carbonate that then settles to the bottom. And we proved that there were, in fact, carbonate ions in the in the soda water. So the reason why I wanted to do this is I wanted to show you that at its core, people always talk about, and you probably have heard this in other classes or other classes you've taught, the scientific method. And my big thing is the scientific method is not some rigid set of rules we have to follow. It is the intuitive way that we go about investigating the world. That with our soda water and our tap water, we started with observations. Hey, these are different. I wonder what makes them different. Oh, we call that carbonation. Maybe that has something to do with it. And so then we made a hypothesis that perhaps it was these carbonate ions that had something to do with the difference between soda water and tap water. And then we did a little experiment, and then we were able to make a conclusion. Now, one of the things I like to stress here is that one experiment done one time is not enough to really conclude anything. Because we can make false conclusions. It's pretty easy. Also, I would stress here that if your hypothesis is wrong, that doesn't mean you had a bad experiment. It just means your guess was wrong. But then the quality of the experiment is something different. Depending upon what you want to do here, you can really expand and look at what is the quality of science, what makes good research. Because like when you see that article says, hey, eating chocolate's good for you. Well, what about how many times has that research been done? How well was the experiment done? What were their controls? That kind of thing. So all that comes into play. Another part of this, what is science, that so many people get this wrong, and it drives me batty. Okay? The number of times I hear people say that a law is just a stronger form of a theory drives me nuts, because that's not what a law is. They are two distinctly different things. So first and foremost, a scientific theory is an explanation, keyword there, explanation, supported by a wide base of data and experiments. So for example, the theory of evolution is trying to explain how speciation occurs, how one family of finches could have landed on the Galapagos Islands, and then by the time Darwin gets there, there's all these different varieties of finches. Okay, good old natural selection. Einstein's general theory of relativity is trying to explain how gravity works, what's going on with the bending of space-time and the such like that. In contrast, a law is a description. It just simply describes it. So for example, the law of gravity, Newton's law of gravity. It just simply says, hey, if I have these two things with this mass and they're separated by this radius, this is how much gravitational force they feel. It doesn't try to explain where or how or why the gravity occurs. It just simply says, hey, this is what happens. Law of conservation of mass. It doesn't try to explain why mass is conserved. It doesn't try to give you a mechanism by how it's conserved. It just simply says, hey, it's conserved. And so that law is a description in contrast to the theory, which is an explanation trying to explain how. Right. Which brings us to types of research. So within science, we have two types of research, what we call pure research. And its goal is purely knowledge for knowledge's sake. Hey, I want to know what happens. This is kind of basic curiosity. I did a research project in college, and people asked me, hey, what's the goal? I'm like, to learn something. We were trying to see if a type of bond was possible. And it didn't really serve an industrial purpose or anything like that. It was just simply, hey. And so pure research falls under your pure sciences, chemistry, physics, and biology. In contrast, we have what we call applied research. And its goal is understanding or solving a particular problem. This would be things like medicine or engineering. We're trying to understand why this person with ALS gets sick. We're trying to understand how Alzheimer's works. We're trying to figure out how to make a medicine that cures cancer. We're trying to build a better bridge that costs less but more structurally sound. That's all those come into play, but those also still involve chemistry. They still involve the chemistry and the physics and the biology that are the pure research ideas, but they've been used in applied research. Medicine's all about biology and chemistry. Engineering is all about chemistry and physics. And so that all comes into play. So congratulations, you've ended the first video, your first lesson. Be sure to work through some problems in the workbook, and then I will see you in lesson number 2.